Whoa, that's pretty cool. This is what I said to myself back in 2013 when I saw this on NASA's astronomy picture of the day. But back then, I wasn't entirely convinced that Andromeda Galaxy was indeed so large. Is it really 6 times bigger than the moon itself? Because seeing Andromeda in the night skies in real life and also using all sorts of simulations kind of gave me an idea that it was much smaller. But the new research that came out very recently suggests something completely different. It actually suggests that it's much bigger than we ever imagined. Hello wonderful person, this is Anton, and today we're going to be talking about the Andromeda Galaxy and the sheer ridiculousness of the entire size of this beautiful galaxy. And we're going to start with this right here. This is a composite image showing us what the Andromeda Galaxy and its incredibly large halo would look like in the night skies if we were to look at it and if we were able to see the halo itself. And of course, if you compare all of this to the size of the moon in the night skies, this would practically be like looking at a very large cloud, an actual cloud that would cover pretty much everything out there. But the thing is, we don't really see the halo, and we don't even see Andromeda that well. Mostly because you have to be in a pretty dark environment to see it, and usually either the sun itself, or more typically the light pollution from various artificial lights around the planet prevent us from seeing this galaxy in its true beauty. Nevertheless, this is the closest large galaxy to us, so everything about it is kind of fascinating. Now, at a distance of about 2.5 million light years away from us, it does seem pretty far away. But it turns out that just as we talked about in some of the previous videos and in some of the previous research, the size of this galaxy suggests that the Andromeda and the Milky Way have actually already sort of started to collide. Not the galactic matter that we can actually see very well, but the halo matter that's present both in the Andromeda and the Milky Way galaxies. And some of the previous research has even suggested that the matter that's colliding right now has already started to create new stars and possibly even new planets in between our galaxies. But what exactly was recently discovered, and what exactly does this mean for the future of two of our galaxies? Well, first of all, the major discovery in the paper is the sheer size of the halo itself. It stretches anywhere from 1.3 to about 2 million light years away from the center of Andromeda Galaxy, which would make it look something like this in the night skies if we could actually see it. The discovery also suggests that the halo itself seems to contain at least 2 major layers, with one inner layer being around 500,000 light years in diameter, but being very complex, extremely dynamic, and filled with a lot of heavy elements, a lot of complexity, and no actual very easy to define shape. It's somewhat amorphic in that sense. At the same time, the outer shell that extends up to about 2 million light years does seem to be more smooth, but it's also hotter and doesn't contain as many heavy elements. And to try to understand the main reason behind these differences, you just have to imagine what happens in the center of a typical galaxy. Here, it's not surprising to discover a lot of various activity, a lot of different supernova, and a lot of other very powerful activity that then reshuffles this material, making this region very hectic and also very complex. At the same time, the outer regions of the galaxy, because they wouldn't really be experiencing supernova or any other powerful events, and because they would have much longer time to evolve, would be much smoother, but also due to various magnetic interactions and possibly also due to the mysterious dark matter, the temperature here overall would be much higher. Which actually brings me to the next point. What is halo anyway? What exactly is it made out of? Well, today the scientists are not entirely sure, but we believe it has at least 3 main components, which by the way is completely absent in this simulation. This here is just the visual matter, the stars themselves. Here we don't really have much else to show. But today we expect a typical galaxy to also contain quite a lot of stars on the outskirts, which I kind of tried to create in this simulation. And so there is quite a lot of various star matter, a lot of globular clusters, a lot of other smaller components present pretty much as far away as 2 million light years away from a galaxy. At the same time, there is something known as galactic corona, which usually contains a lot of dust, which we're gonna try to add here as well. This is usually what causes various galaxies to become active, and also what causes a lot of galaxies to suddenly become starburst galaxies and have very active star-forming regions which normally is caused by these large chunks of gas just circulating around the halo and coming back into the galaxy once in a while. One of the most famous examples of these galaxies in the universe are these beautiful antenna galaxies where you can see all of the brightness is created by various types of stars being created in these starburst regions. So this is something that happens to most galaxies once in a while. But stars and of course gas here is only a very small part of the entire halo itself. The biggest part of the halo is of course the mysterious dark matter. Something that we know exists, but we're just not entirely sure what it is yet. And so for the most part, this is what a typical galaxy would sort of look like if you could see everything. There's lots of dark matter, which represents the biggest part of the galaxy. There's a lot of gas, there are occasional stars, and most of it is practically invisible, only visible to some extent in the ultraviolet light. But seeing the UV light from planet Earth from within the atmosphere is impossible because it's absorbed by the atmosphere. So we have to use space telescopes, something that orbits planet Earth or something that's farther from planet Earth, to be able to see the UV light that might be emitted by the halos. Naturally, this is exactly what the scientists did by using the Hubble telescope through the so-called Project Amiga, which was able to observe various types of emissions from the Andromeda Galaxy. And they did this in a pretty clever way. Since the Andromeda Galaxy is so large compared to even the moon in the night skies, naturally some of the farthest objects, specifically here extremely bright quasars, are naturally going to be shining through the galaxy itself, and we're going to be able to see the emissions from these quasars and thus be able to detect what sort of material and what sort of gas all of this comes through. But here they obviously weren't looking at the visible part of the Andromeda and instead focused on the parts where they believed the halo to be located, just to see if any of the light from these distant quasars is going to pass through something that appears to be near the Andromeda. And they were able to identify 43 different quasars whose light passed through the halo or very close to it, thus allowing them to limit the actual shape and potentially the size of this halo, suggesting once again that it's roughly around 2 million light years in radius. Now, trying to do this for most other galaxies would be kind of challenging simply because they wouldn't really be close enough or large enough in the night skies to present such an opportunity to define something as halo, and because they would maybe just have one or two quasars shining through them. But the sheer size of the Andromeda in the night skies definitely made it much easier for us to see what's going on here and define the invisible halo around it. This also means that as our telescopes improve, we'll be able to see even more objects shining through the halo of the Andromeda and thus see and define it even better. Which of course allows us to understand what our own Milky Way looks like, because the two galaxies are somewhat similar in shape and in size. In other words, it's almost as if we're looking at the mirror image of the Milky Way itself. It might be a little bit bigger in some sense, but in terms of the actual halo and everything else, it's probably similar to what we have in our own galaxy too. But some of the more surprising findings here is of course in regards to how complex and how extremely unusual in terms of shape and size this whole structure is. It seems to also contain a lot of very strange ionized gas all over the place, including gas containing ionized carbon, silicon, calcium, and so on. And all of this suggests that these were most likely created by ancient supernova, and also a lot of really powerful radiation stripped these molecules of their electrons to turn them ionized. So a lot of really powerful stuff is definitely happening in these halos, allowing them to become massive, very large, and extremely energetic. Not to mention really hot, millions of degrees hot. But we still have a lot of other telescopes coming up that will improve our ability to see all of this even better in the next few years. First of all, we have the famous James Webb Space Telescope that's going to be significantly larger than Hubble. And then, if everything goes well, by 2039, we're going to have the very interesting Large Ultraviolet Optical Infrared Surveyor, simply known as LUVOIR or LUVOIR, I guess. And this telescope is not really coming anytime soon. It's sort of planned for 2039 right now. But if it does arrive, it's going to allow us to see some absolutely incredible things, because the mirror here is ridiculously large. But for now, it's still pretty exciting to discover that the Andromeda is still larger than we even initially thought, and might even grow larger in size as we discover more things around it. So even though this is already mind-blowing, technically, the halo itself would produce the largest object in the night skies, but only if we could see it. For now, we're just going to have to imagine it. Anyway, once we learn more about the Andromeda or discover something else incredible about the halo of the galaxy, I'm going to For many years now, I've been speculating that we're going to find even more signs of life on Venus. And, well, looks like we got what I was asking for. Hello, wonderful person. Let's talk about this new discovery, very exciting discovery that suggests that there might be something happening on Venus after all. But I'm not going to go on a limb and say that this is life for sure, because it could be something else. Let's talk about this in a little bit more detail. And begin with a cautionary tale of the past from our neighbor Mars. You might have morphology, or shapes in other words, to suggest that life was found, because if something looks like life, it doesn't really mean it's life. On the other hand, if something smells like life, is it life? Well, chances are that it can still be just a chemical reaction, which is pretty much what we found on Venus now. So we found these molecules known as phosphines, not to be confused with phosphines, which apparently is spelled just a little bit different but means a completely different thing. So we're talking about this, not this. This here refers to a psychological perception of light without any light being produced. So in other words, this is a completely different concept. This here is a molecule, and this molecule is also extremely toxic. As a matter of fact, in the last few years, several major incidents occurred when this molecule leaked somewhere, resulting in several fatalities, and this is something that actually happens every few years here and there. So this is a pretty dangerous gas. But how can a dangerous gas be connected to life? Well, it turns out that here on the planet Earth, the only way we've discovered that this gas is produced is with certain bacteria, so-called anaerobic bacteria that does not require oxygen. A lot of different types of these anaerobic bacteria exist on our planet. Some of them can even be found inside of you right now, inside of your guts, and they do produce all sorts of different gases. By the way, completely not related, but that's exactly where the gas comes from when you pass gas. It's the anaerobic bacteria producing all sorts of stuff inside of you. But certain bacteria do produce phosphine, and for what reason we don't really know. There have been speculations that maybe it's used as a kind of a protection. Because it's toxic, maybe some bacteria use it to kind of cover their area with it so that other bacteria don't get in there. And so it could be used as a sort of a protection for various types of bacteria, or it could be just their waste. We don't really know what phosphine is for. But we do know that on Earth, no geological or chemical process ever produces it. It's always bacteria. It has even been suggested that phosphine is a very important part of the phosphorus cycle on our planet. Essentially, this is how phosphorus is recirculated and reintroduced back for other life to use. But all of these are very early assumptions because we just don't know enough about it. But then again, we've actually found phosphine on other planets, specifically our large cousins Jupiter and Saturn. Both of these do contain a lot of phosphine. And so today the scientists believe that it can be produced in extreme conditions in these gas giants. Extreme pressures, possibly extreme temperatures do produce phosphine in inorganic ways, which once again takes us back to Venus. As it usually happens in science, this was a completely accidental discovery. As a matter of fact, the scientists were almost doing the opposite. They were using this beautiful telescope known as James Clerk Maxwell Telescope to try to rule out extreme scenarios and to try to establish a kind of a base for what we should be looking at when looking at other planets. Now, this telescope is able to observe in sub-millimeter range and is able to see certain wavelengths in extreme precision. And it just so happens that one of these wavelengths is apparently the absorption spectrum of phosphine as well. Now, this is where I actually don't know enough about chemistry to speculate that maybe there is another chemical out there that could be similar to phosphine in that sense. So if you do know enough about chemistry, please let me know in the description, because maybe it's just a chemical that's very similar to phosphine, has a similar absorption spectrum, that's not phosphine. Anyway, long story short, they used the telescope, they looked at Venus, specifically the absorption spectrum, and they saw the spectra that are very similar to phosphine. And this, of course, was very unexpected. They did not expect to find this in the atmosphere of this planet. Now, you might have seen my older video from a few months back based on another paper that very strongly suggested that phosphine can only mean alien life. And in retrospect, I sort of regret making the strong statement, because now I'm doubting myself. What if there are ways for phosphine to be created inorganically? And what if Venus actually has one of these conditions for phosphine to be formed? Now, right now, our understanding of how chemistry works on other planets is not particularly good, because we haven't really been able to create a lot of situations where Venusian conditions, for example, are recreated. And here we are, of course, talking about 93 atmospheres of pressure and almost 500 degrees Celsius of temperature. So in that sense, maybe there is something going on here that makes this possible without any bacteria whatsoever. But then on the other hand, if you've been on the channel long enough, you probably know that I'm a strong believer and a proponent in thinking that there is definitely life on Venus. I'm just not entirely sure that this was the sign of it. Maybe one of the signs, but not a definitive sign. And by the way, a lot of the speculations and a lot of the ideas behind life on Venus began when we started observing unusual formations inside the clouds of Venus that were absorbing the light coming from the sun in a very unusual and very peculiar manner. These so-called light absorbers, as they're known today, are still a mystery and are definitely yet another sign that life could be present on Venus after all. But the other obvious reason why we believe life is totally possible here is because life can exist in the upper atmosphere. One of the previous papers I've mentioned had this beautiful illustration in it, suggesting that, well, right around here, around 50 to maybe even 70 kilometers above the ground, is where life can definitely exist and even thrive, because we get about 1 atmospheric pressure, which is similar to Earth, and the temperatures are also very similar to what we have on the surface of the planet. The only difference being that it's also a little bit more acidic. But we also know that here on Earth we have extremophiles that absolutely thrive in acidic conditions. We found them everywhere on the planet, especially in extreme, very hot, very acidic places. The most famous example, of course, is the Yellowstone National Park, which is what you see right here. And these bright colors are all bacterial in nature. This is all produced by all sorts of different extremophiles. So in that sense, finding life in there is totally not unusual. It's just we haven't really had enough signs of life yet. We have visual signs,